Hello, good afternoon, everyone. Today, I will give a presentation on how to run your apps on Carrier Edge and to share the Mac open source solution. First, I will give a brief introduction for myself. My name is Gabriel Yu, come from Huawei. I've been involved in open source world for almost 6 years. Now I'm the TSC chair of Edge Gallery and a 5G Mac open source community, and also Eclipse Edge TSC member. My other roles include PTL of Linux Foundation, OpenMV Bottlenecks project, committers of several Linux Foundation and Kernel project. Um, my presentation include basically three parts. First, I will introduce the background of 5G Mac and some basic requirements from developer experience and technical architecture. Mm, First, we see Mac. A 5G Mac is a key tool for carrier in A2B market. Mac has its own unique advantages. First, a 5G Mac is one of the most important and critical type of edge computing. According to Gartner's industry operation curve in 2017, edge computing is still at the peak of the hype. Today, by 2020, we think that edge computing has passed the bubble through and is starting to climb steadily. As the commercial deployment of 5G accelerate, we believe that edge computing will become a necessary requirement for all digital services by uh, 2022. 5G MAC is a natural extension of 5G network. In a 5G era, the core network architecture expanded from a central architecture to distributed architecture to provide deterministic connectivity services. Mac is one of the key technology in this change. 5G Mac is short for multiple access edge computing, which extends the computing capability of UPF on the core network. Mac is a network platform which implements the connection capability and also a computing platform that allow cloud contents and application to be deployed at the network edge close to users. 5G Mac provides powerful computing capability compared to peer devices. It supports higher computing capability on devices, reducing device cost. 5G features high bandwidth, low latency, and massive connections. Combined with Mac's edge computing and the capability, 5G builds the connection, computing, and open capabilities required by vertical industry, meeting application requirements of many vertical industry. From industry perspective, almost all industries such as media entertainment, smart grid, transportation, healthcare, smart city, uh, etc., need to be upgraded digitally. Recently, as the new coronavirus has caused a surge in demand for online education, online medical care, and online collaborative office, as long as there were many people in those system user experience or relatively poor. We hope that 5G Mac can solve this problem. From the technical perspective, 5G Mac enable 8 new vertical applications, which include ultra high definition video, intelligent surveillance, VR, MR, robot, remote control, drone, and some surveillance tracking. We believe that 5G Mac is not only a product that with physical box and of powerful computing capability, but an application platform with rich automatic capabilities. We can compare Mac to smartphone, which are actually pre-installed with a lot of services and apps. Today, smartphone applications are generally tens megabytes, not much. This is because smartphones provide many basic capability and services for application to invoke. The development based on 5G Mac can be summarized as follows. First, developers should select microservices frameworks, development languages, APIs for defining applications to be released, and atomic platform capabilities provided by Mac. Generally, developers select mainstream microservices frameworks and define APIs to be exposed in details. After the first three steps are complete, um, application development depends on platforms such as ARM, x86, Kubernetes, or OpenStack. For developer, different computing architecture and ICE platform are required. The difference is very big. The experience varies with different languages on ARM and x86 platform. Applications developed based on Kubernetes or OpenStack are also very different in form of deployment or networking or management. Generally, developers select a development platform based on their application scenarios and skills. After the development platform is determined, application developers need also to develop and debug application based on a mature continuous release and integration system. And finally, publish their application on a public store or somewhere to get more attention. From the preceding process, development experience is very important for developer, which directly affects the efficiency of the entire development process, product quality, and the business benefits. However, from the perspective of developer, which are the experience requirements for development on MEC platform? First, in terms of selecting service framework. Now, there are many microservice frameworks such as Spring Boot, Spring Cloud, Service Comp. The learning cost is high. Different service frameworks are oriented to different programming language and have a long history and supporting libraries. At the same time, developers are often used to one or two microservice framework and require developer to relearn one microservice framework, which is usually costly. This requires that a 5G Mac platform should support multiple frameworks and provide capability such as governance of applications developed based on different microservice frameworks, minimizing developers' learning cost and consistent development experience. Second, from perspective of platform selection or the different computing architecture, the 5G Mac platform should support ARM and x86 simultaneously, and it should also support different deployment type or the management different ICE, such as Kubernetes, OpenStack. I'll come to the third part, which is the critical part. Developers should select the the 5G network capabilities opened by the 5G Mac platform. After a developer selected these capabilities and develop their applications, one of the most important thing is that to facilitate application release, the following requirements must be met. The platform can automatically or manually pack in images. API capabilities can be tested based on platform. Uh, Much more easier deployment of applications, and also comprehensive application ecosystem. This is very important. Automation tools, efficiency improvement tools, quality tools, and ecosystem, including both software and hardware support behind the application, can greatly improve the development efficiency and reduce development complexity and cost. Okay, come to the next part. In addition, from the perspective of industrial trends, application have changed greatly since the virtualization era enters to container era. In the NFV era, uh, all the applications are built in form of virtual machines. But now, almost most of the applications are in form of containers, microservices, stateless. It requires, the more agile development. It's also required the management part to be able to recognize different kind of services to have their properly uh, registered, properly informed, properly management. So according to these um, industrial technology trend, Etsy has defined the 5G Mac reference architecture, which includes basically three parts. The first one is the multi-access edge orchestrator, the MEO, which is responsible for the maintenance of system overview to deploy uh, host available sources. It's also responsible for application package management and other uh, host selection. The second part is MEPM, the Mac Platform Manager. It's responsible for managing the lifecycle of applications, including reporting application-related events to MAO. It provides network element management functions for the platform. It also management both flow rules and DNS rules. The last part is MEC, the Mac platform, which is in short MEP. It provides an environment for service or application discovery, notification, consumption, and it's also receive a flow rule and DNS rule from MEPM. Now, come to the second part. Since we choose open source to build an open ecosystem for 5G Mac. The next part of my presentation is to show that how we can build an open source platform for 5G Mac by using existing components and some integration. So before come to the architecture and the different kind of open source choices, I will introduce three typical 5G Mac applications. The first one is video orchestration and optimization. Video orchestration aims to orchestrate video content sent to users in advanced scenarios, such as multi-camera events, such as football games. In this case, users can select the camera they want to watch. It requires automated coordination, optimization, caching, and then distribution of video files as close to device as possible. No data need to be processed on the core network side. It improve the quality of user experience, improve latency, and free the backcore network. The basic capability required by this scenario is that the network capability provided by 5G. For example, the radio network information, the location, and the dynamic bandwidth. The second parts of the capability required for this scenarios are the VR capabilities, which VR stitching and video orchestration services, so which will ease the development of application running on top of this 5G Mac platform. The platform also needs to provide some basic services such as service registration and service governance. The second scenarios for 5G Mac is CloudVR live TV application. The CloudVR live broadcasting application requires extremely low latency at extremely high bandwidth. Running and processing VR HD video frameworks also require a large amount of computing resources. Similarly, in the case of live broadcasting, the amount of data transmitted over the network will be staggering. Therefore, the best way to provide such services is always to manipulate them on the edge. Similar to the above scenario, the capability required for these scenarios are three parts. One is the 5G network capabilities, almost the same as the first scenario. It includes radio network information, location, dynamic bandwidth. It's also required the QoS. The 5G Mac platform should provide high-speed storage at the edge side for also the video storage and delivery of video contents. Some of the application services as VR stitching, video orchestration, and video distribution service are also required. Also similarly, the basic capability as service registration and service governance or the baseline services of 5G Mac platform. The third typical Mac applications are location-based enterprise applications. The location-based enterprise applications are a very most popular scenarios. 5G Mac can be used for almost every active device location tracking due to their proximity. Geography application hosted on Mac server can request real-time network information from active users. Okay, this comes to the overall view of our open source solution. Basically, compared to the ETSI defined standard architecture, the open source solution have two parts. One is MEC, multiple access edge platform, MEP. The other part is a lightweight MECM. The MECM include both MEAO and MEPM. As we can see from this graph, let's start from left to right, start from the MEP, from bottom to up. So basically, we will support different kind of hardware and to support lightweight OS and lightweight Kubernetes ecosystem software. It's also improve to provide storage, to provide different kind of services, including 5G network services and vertical intertree enablement services. In addition, it will also provide some of the tool chains to ease and to accelerate the application development. For example, the Eclipse IDE, our Eclipse IoT tools include Eclipse Capra, Cora, Hono. Also, for this edge node, which installed MEP. It supports self-management, offline management. That means even if the edge node is disconnected with MECM, the edge node can management itself, including the microservices, including the storage, the data. It will constantly um, communicate with to check with MECM if the connection is recovered. Once the connection is recovered, it will synchronize all the basic informations with and the data with MECM. To the right part is MECM. It's include both MEAO and MEPR. That means it will management the basic system, overview. It will also to management the life cycle of applications. Uh, Not that it's just a lightweight solution for the Etsy definition. It's only include some basic functions. Uh, okay, uh, let's come to the last part of this technical review. The second part. Um, so now we have Edge Gallery community. The Edge Gallery community is aimed to build de facto standards for 5G edge computing architecture and to enable openness in the telecom field. It's also aimed to lower the threshold for bringing enterprise application on board for large scale and to build a B2B business ecosystem. Um, it the basic technical architecture is the same from the formal slide. So it has 5G native connection capabilities. It will also build edge native platform architecture to diversify the open ecosystem, not only the uh, software application, but also to support different kind of hardware computing architecture. Okay, now comes to the last part of my presentation. In this part, I will give a introduction of how to implement edge application development based on the open source solution. Basically, it required 4 steps to develop and publish your own application on this open source platform. The first step is to prepare the open source environment. Developers should download the open source 5G Mac software platform and choose a proper server to install it. That means developer could buy some servers, and it could also apply for sandbox resources to the open source community. So after the open source 5G Mac platform are installed, the developers should choose the SDKs, tool chains provided by this platform, and to develop application based on the selected capabilities and the defined APIs. After all these development are finished, the developer should also release this application on the open source platform. That means it should upload their application or to test their application in the sandbox resources in our open source community. And after the application pass all the test, all the verification, the application profile. That means the description of the application and some app description file will be uploaded to our app store. Um, that's the end of the third step. As to the last step, it's to deploy application, but that is not strictly rigorously relate to the development. It's only the last one. If some users or the buyers or some of the testers want to do some test their application, want to use their application for different kind of purpose, it could deploy this application through MECM. The MECM will synchronize apps from the App Store, and one user should select a desired applications and to deploy the application on a desired edge node. Okay, this is the end-to-end DevOps tool chain based on open source solution. That means our open source community and open source platform will provide the end-to-end tools and open including both software and hardware for the DevOps. The community will provide sandbox. The developer or a company could build their DevOps tool chain based on the community sandbox. It required a developer or a company to download all the required tools, required software to connect their development pipeline to the community sandbox, so that they can do real-time development, real-time testing regarding the 5G network sandbox resources. So this is the labs we are planning and already having in our HGather community, which in now it's there are basically two locations for the 5G NAC, 5G network. They are all in China, but we plan to build more lab worldwide. Now we have some servers in Beijing, Nanjing, and Shanghai, and some 5G network in Shenzhen and Nanjing. So our release CI/CD pipeline and also our sandbox will be provided based on these labs, and developers and other companies, member companies can apply for sandbox and apply for the resources according to their needs. Okay, that comes to the end of my presentation. I will give a brief introduction about the technical consideration of a 5G MAC open source platform. The open source 5G MAC solution is a common foundation for carrier network MAC, including the MEP running state, support heterogeneous hardware and virtual computing platforms, unified application and service management, unified network capability, exposed APIs, and the unified MEP management interface. It's also support the 5G MAC management orchestration, which includes a unified application lifecycle management and resource and application monitoring. So the third part is 5G MAC application market. That's a unified application market used to monetize application values. The last part is that open source platforms should provide 5G MAC development tools, provide code integration of standard MAC API, and also to packet to test the applications. Different problems may occur when using the developing open source platforms such as container image generation, development, test, and deployment dependency. And I think welcome to the community and ask questions. There are three links listed at the bottom of this page. And welcome to send our email or raise any question on our website, and we're very excited and very welcome. Thank you. Thank you for your participation today.